Okay guys, so this is the start of something called exact values, which is going to be something that comes up a lot this year and is actually going to be really important for calculus. So what we're going to start off doing is we're going to find the sine, cosine, and tangent for a 30-degree angle. And normally if you guys had a calculator, you can do this just by typing those numbers into the calculator and finding a value. But if you were to type in something like the cosine of 30, you would get a decimal value like 0.86 or something along those lines. What we want is, instead of a rounded decimal, we want exactly what that answer is going to be, because we want to try to avoid rounding. So to find all of these, the way we're going to do it is that we are going to draw that triangle. So what I'm going to do is I'm going to make my little coordinate plane here. I'm going to draw a 30-degree angle. All right, and what I'm going to do with that, is I'm going to turn that 30-degree angle into a triangle on the x-axis. Now if you guys remember when we talked about reference angles were always made with the x-axis. So I'm going to do these triangles the same way. I'm always going to make them with the x-axis. So that makes this 30 degrees. So now what I'm going to do is, in order to find the sine, cosine, and tangent of that angle, I'm going to use my basic trig operations. I know that sine is opposite over hypotenuse. So what I need to do is I need to fill in this triangle with my opposite and hypotenuse values. Now, since I know I have a 30-degree angle and I know that I have a 90-degree angle, the missing angle up here has to be 60 degrees. So what that means is I have a 30, 60, 90 triangle. And if you guys remember those ratios, it was x, x root 3, and 2x. So we can pick any value for x we want, and that ratio is going to be the same. So what I'm going to do is I'm going to pick the simplest ratio possible, and I'm just going to say that x is equal to 1, which gives me a value of 1, root 3, and 2. So what I'm going to do now is I'm going to fill in those values on my triangle. So across from 30 is 1, across from 60 is the square root of 3, and across from 90 is 2. So now using these triangles, I can find those different values. The sine of 30 degrees is the opposite over hypotenuse, and if I look at 30 degrees, opposite from 30 is my 1, and my hypotenuse is 2. So that means opposite over hypotenuse is 1 over 2. So that means the sine of 30 degrees is 1/2. And if you were to type in the sine of 30 on your calculator, as long as your mode is in degrees, you would get 0.5. Alright, so now let's try it with cosine. My cosine ratio is adjacent over hypotenuse. And I'm going to solve this the same way. I look at my adjacent side to 30, so next to 30 is the square root of 3, and my hypotenuse is still 2. So that means that my cosine of 30 degrees is root 3 over 2. Now remember, this is the exact value. So if I were to type in cosine of 30 degrees in the calculator, I would get a decimal value of about somewhere around 0.866. Now if you were to type in the square root of 3 divided by 2, as long as you did your parentheses right, you would get that same decimal answer. Okay, so those are the same values, but the square root of 3 over 2 is the most exact answer that I could get. So then the last one we're going to do tangent. So again, I'm going to use that same triangle. And if I look at tangent ratio is opposite over adjacent. So the tangent of 30 degrees is going to be equivalent to my opposite side over my adjacent side. And that works out to 1 over the square root of 3. Now if you want to rationalize the denominator, you can. You don't have to, but if you did that, you would get root 3 over 3. So you might see that as well sometimes as your answer. But what these are all of the exact values for the sine, cosine, and tangent of 30 degrees. If I wanted to find some of my different values, I could. Let's say I wanted to find the cosecant of 30 degrees. I could do that two ways. I can either take the sine ratio and flip it, and I would get 2 because they're reciprocals. Or if I wanted to, I could do this with hypotenuse over opposite, and my hypotenuse is 2, my opposite is 1. Either way, I still get 2 over 1. Okay, for our next example, we are going to have to use reference angles. So I want to find the sine of 120 degrees, and I'm going to start this the same way I started the other one. I'm going to draw a 120 degree angle, which I know is going to end up in quadrant 2. That's my 120 degree angle. Now if you remember, these have to always be drawn with the x-axis. So I'm going to still draw my right triangle. But what's different now is I know that that distance is 120. What I need to know for my triangle is the reference angle. This is the reason why we had to figure out reference angles. So if you guys look at this picture, I know that my reference angle is going to have to be 60 degrees. So now that I have my reference angle, what I can do is I can fill in this triangle just as I did in the last one. I still have a 30, 60, 90 triangle, and I'm still going to use the simplest ratio possible, which is going to be 1, root 3, and 2. So I'm going to fill in my triangle. Across from 30 degrees should be 1, across from 60 degrees should be the square root of 3, and across from 90 should be 2. Now the difference this time though, if I look at this picture, if you think about a normal XY axis, let's get kind of messy. If you think about a normal XY axis, if I travel to the left on the x-axis, those values are negative. If I travel up on the y-axis, those values are positive. So I need to make sure I mark on this picture, it's going to make it different, is all the way to the left, this 1 is going to be a negative 1. So it's going to change some of my values slightly. So now, when I find the sine of 120, that's still going to be opposite over hypotenuse, my opposite of my reference angle. So opposite of 60 is the square root of 3, and my hypotenuse is 2. So the sine of 120 degrees is root 3 over 2. But what's different now, let's say I wanted to find the secant of 120. So secant, my ratio is hypotenuse over adjacent. My hypotenuse is still 2, but this time my adjacent is actually a negative value. It's a negative 1. So the secant of 120 is actually a negative 2. So we can get negative answers depending on which quadrant we draw our angle in. Okay, now let's say I want to find the cotangent of a negative 135 degree angle. So the first thing I'm going to do, just like always, I need to draw a negative 135 degree angle. And I know if I'm going backwards, that's going to be in the third quadrant. So I draw my triangle in the third quadrant, and I make my triangle, again, always with the x-axis. So I know that I went 135 degrees that direction. So I need to find my reference angle. So my reference angle in between that 135 and that 180, that angle is going to be 45 degrees. So I can still figure out this triangle, except this time, instead of being 30, 60, 90, this triangle is going to be 45, 45, 90. Which just changes my ratio. My ratio is x, x, x square root of 2. And again, I want to fill in this ratio the simplest way possible. And the simplest way is if x is 1. So that gives me a value of 1, 1, and root 2. So I'm going to fill in those values in my triangle. I've got across from 45 is 1, across from 45 is 1, and across from 90 is root 2. But now I need to look at is see which of these values would be negative. So both ones are actually going to be negative because I'd be traveling in the negative direction in order to get those. So once I have my triangle filled in with my values and my signs, I can just look at the ratio. Cotangent is the ratio of adjacent over opposite, and adjacent to that 45 degree original angle is a negative 1. Opposite of it is a negative 1. So what that gives me is a negative 1 over negative 1, which is the same thing as a positive 1. So the cotangent of negative 135 degrees is positive 1. Alright, now we're going to move on and we're going to do some radian examples. Now, radians actually can be a little bit simpler than degrees when you find your reference angle. What's tough about radians is trying to figure out which quadrant they should go in. So what's really nice about radians is if you look back at our unit circle, the different colors we made, that was because of our reference angles. So if you look, all of our pi over 6 values have a reference angle of pi over 6. So any value that's pi over 6 is going to have that reference angle. Now, what's really helpful for you guys to learn is just simply to remember pi over 6 is equivalent to 30 degrees. Pi over 4 is equivalent to 45 degrees. And pi over 3 is equivalent to 60 degrees. Because these are the radian values, the radian reference angles you're going to see the most often. And that just got really messy again. Let me fix that. Alright, so now, again, the hard part about these with radians is converting quadrant again. So if I convert pi and 2 pi to a common denominator, this is going to be 6 pi over 6, and this is going to be 12 pi over 6. So if I think about then, 11 pi over 6 then is going to have to be in the fourth quadrant. So I draw my triangle with the x-axis. My reference angle I know is pi over 6. So when I fill that into my triangle, I know a reference angle of pi over 6 is the same thing as 30 degrees. So I'm going to fill in my triangle with a reference angle of 30. And now I'm going to do this the exact same way I've been doing it. Across from 30 is 1, across from 60 is root 3, and across from 90 is 2. And then just fill in my positive and negative values. If I'm going down in the negative direction, then that 1 has to be negative. Root 3 is positive because I'm going in the positive direction of the x-axis. Now I'm going to find my values. Cosine is the ratio of hypotenuse over opposite. My hypotenuse is 2, and my opposite side of 30 is a negative 1. So that means the cosecant of 11 pi over 6 is negative 2. Okay, we're going to do one more radian example because these are a little bit trickier. And we're just going to follow these basic steps that we should do for the whole thing. So the first thing we need to do is determine which quadrant to draw this angle in. So I'm looking at 4 pi over 3. I know 1 pi is 3 pi over 3. And I know 2 pi is 6 pi over 3. So that means that 4 pi over 3 is going to fall just a little bit after 3 pi over 3, which is going to make this triangle in quadrant 3. Okay, then I'm going to determine my reference angle. So I'm going to draw this with the x-axis, and I need to figure out what my reference angle is. My reference angle is going to be pi over 3 because my radian value is pi over 3. And I know that pi over 3 is equivalent to 60 degrees. So this is a 60 degree, 30, 60, 90 triangle. So I'm going to fill in my triangle now with my values, but not just with my values, also with the appropriate positive and negative signs. So across from 30 is 1, across from 60 is root 3, across from 90 is 2. If I travel to the left, it makes a negative 1 and a negative square root of 3. So now all I have to do is just find my value using my trig ratio. Secant is hypotenuse over adjacent. My hypotenuse is 2. My adjacent is negative 1. So my value is negative 2. Now the last angles we're going to look at are the angles that fall exactly on those lines in between quadrants. Because if I get an angle that's right on that line, I can't draw a triangle. I have to try to solve these a different way. Now there's two different ways that we can solve this. The first one is going to be to think about these points. Okay, now when we talk about the unit circle more in class, we're going to talk a lot about those coordinates. So if you think about these points right here as a radian, if I have a radius of 1, the value of this point over here, those coordinates of that point, would be at 1, 0. At 90 degrees, the coordinates of a point right there within a circle with a radius of 1 would be 0, 1. Over here at 180, that would be at negative 1, 0. And then finally down here at 270, that point would be 0, negative 1. Now if I can remember those coordinates, if you just think about if I were just to plot those points, what those points would be with a radius of 1. What makes these really simple to figure out is I know that my cosine is always the x-coordinate. I know that sine is always my y-coordinate. And I know that tangent is always my y divided by my x. So what that means for me is if I were to try to find the sine of 3 pi over 2, I would simply look for 3 pi over 2, which is this line right here. I look at my two coordinates. Sine is the y coordinate, so the sine of 3 pi over 2 is simply -1. Let's say I wanted the tangent of 180 degrees. I look at my y coordinate divided by my x coordinate, and 0 divided by anything is 0. Now there's one more way I can remember these, and this is a different way that a lot of people will use, but I want you guys to be careful if you learn it this way, because you have to make sure you learn everything on it. So there's a little chart that I can use to help me remember these. But what you have to remember is these things I have written down right here. At the top, in this order, I have sine, then cosine, and then tangent. Okay, so remember that's backwards between the x and the y coordinate. So this is sine, then cosine, then tangent. Then down the side, I start at 0. I go to 90, 180, and 270. If I want to do that in radians, okay, remember that would be pi over 2 radians, pi radians, and 3 pi over 2 radians. So there's a little way that I can remember these. And there's a little saying. It starts with O, I, O. I, O, U. O, I don't O. I don't owe you. Okay, so I'm going to say that one more time where you can actually look at it. O, I owe. I owe you. O, I don't owe. I don't owe you. So the don't owes are my negative ones. Okay, my i's are my ones, and o's are zeros. Okay, what U stands for undefined. And undefined happens whenever I'm dividing by 0. So if I were to look at, say, the tangent of 90 with my coordinates, that would be a value of 1 over 0, which is undefined. So again, this is just another way to learn these border angles. So let's say I want the sine of 180 degrees, it's 0. Alright, so one more time, it's O, I owe. I owe you. O, I don't owe. I don't owe you. So let's say, for example, I want the cosine of pi. Looking at this little chart, the cosine of pi is -1. So the cosine of pi is a -1. And that's it. We're going to do a little bit more with exact values tomorrow, but that's just more of looking at the unit circle and then doing a little bit more computations with these values.